This module covers the drive motor battery assembly in the 2017 Cadillac CT6 plug-in hybrid electric vehicle, or PHEV. A PHEV is designed to provide all-electric driving for most daily commutes while maximizing fuel efficiency. This is achieved by combining power from the engine and a high-voltage motor at higher speeds and higher loads. The electrical energy supplied to the motors within the transmission is controlled and distributed by the power electronics. The drive motor propels the vehicle and also serves as a generator, so it is often called the drive motor or generator.
Select the next active link to continue.
The HV hybrid EV battery is located in the rear storage compartment and is installed from beneath the vehicle. The HV hybrid EV battery contains individual cells that are welded together in parallel, forming a cell group. These cell groups are electrically connected in a series. The battery cell groups are joined to form 3 distinct sections. Each battery section contains 2 temperature sensors for a total of 6. The drive motor battery system consists of many components that operate together to provide energy to the vehicle. These components are controlled and monitored by the Hybrid Powertrain Control Module 2, or HPCM2. The battery is an 18.4 kilowatt-hour lithium-ion pack that is located between the rear seats and the trunk and carries a nominal voltage of 355 volts. The battery weighs approximately 180 kilograms, or 397 pounds, and is 71 centimeters, or 28 inches long, 99 centimeters, or 39 inches wide, and 63 centimeters, or 25 inches high. The high-voltage or HV hybrid and electric vehicle or EV battery contains 192 individual cells. Each cell is 12.7 centimeters by 17.7 centimeters, or 5 inches by 7 inches, and is less than 6 millimeters, or 0.25 inches thick. An individual cell weighs 0.5 kilograms, or about a pound, and is encased in a protective polymer-coated aluminum cover. A pair of cells produces 3.7 volts. A pair of cells is soldered together with a coolant plate between, and then placed into a frame to form a group, for a total of 96 groups. Inlet and outlet coolant manifolds are formed when the components are joined together and placed within a frame. Rubber seals ensure the coolant passage integrity. The 96 groups are divided equally into 3 different sections. Section 1 is the upright forwardmost section and contains cell groups 65 to 96. Section 2 is the uppermost section and contains cell groups 33 to 64. Section 3 is located underneath Section 2 and contains cell groups 1 to 32. Cell groups contain non-serviceable integrated circuit board, or ICB, voltage sense circuits that are fused and terminate at a connector. The voltage sense circuits are used to monitor and balance the cell voltage. In turn, the voltage sense circuits are monitored by the Battery Energy Control Module, or BECM. Battery cells connected in a series must have equal voltage levels. Voltage levels are balanced by having excess energy bled off the high-voltage cell and transferred to a cell with lower voltage through transistors. The 3 battery sections are mounted to a battery tray. The tray becomes part of the body structure when it is secured to the vehicle. It is critical that the cover be properly torqued in sequence to the tray, and the tray must be properly torqued in sequence to prevent environmental leaks. The battery sections are joined together electronically by flexible interconnect bus bars and high-voltage cables. The cables also connect the positive and negative battery posts to the contactors and manual service disconnect socket. Note, all high-voltage connections must be properly torqued to reduce the possibility of damage due to electrical resistance. There are temperature sensors located at each end of the battery sections to monitor the temperature of the section. The temperature sensor located in the battery coolant heater monitors overall battery temperature based on the coolant temperature. The BECM is mounted to the top of the battery and monitors several battery states: voltage of each cell group via sense circuits, cell temperature through 7 sensors, and overall battery amperage using a current sensor. The data collected from the sensors and circuits is communicated to the Hybrid Powertrain Control Module 2, or HPCM2, for processing and viewed in the BECM data list. Caution: during service, the connectors of the BECM must be disconnected and reconnected in a particular order to prevent internal damage to the module and/or battery sections. In addition, all connectors must be removed when performing any diagnostics or service procedure that opens volt sense wires. The BECM is powered by the battery sections and therefore can perform cell balancing even when not connected to the vehicle. This could cause an unrecoverable out-of-balance situation. The Manual Service Disconnect, or MSD, is a safety device that physically separates the HV series circuit within the battery. The MSD incorporates a 250 amp fuse that will open if a short occurs between the high voltage cables. The MSD also incorporates an interlock circuit. The drive motor battery wire junction block and relay assembly is also called the Battery Disconnect Unit, or BDU, and contains the following components: contactors, fuses for each HV component cable, current sensor, and low-voltage wiring connections. The HPCM2 is the main controller for battery operations. The HPCM2 directly controls the contactors within the relay assembly and monitors the HV interlock circuit. High voltage is contained within the drive motor assembly when the ignition is in the off position. In the power on mode, the HPCM2 checks for conditions that would prevent the contactors from closing: a vehicle crash, airbag deployment, high voltage interlock circuit or HVIC open, battery too hot or too cold, and contactor issue. If no issues are found, the HPCM2 will close the high voltage contactors in order to provide energy to the high voltage system components. During vehicle operation, the main positive, main negative, charge positive, and pre-charge negative contactors work together to complete the current path to the high voltage system. Contactors must be closed in a particular order to prevent damage to the contacts from electrical arcing and to prevent the large inrush of current to the capacitors. The charge positive, main positive, and pre-charge contactors are closed. Current flows through the current limiting resistor. Once voltage is equalized on both sides of the main negative contactor, it is then closed and the pre-charge opens.